In this video, we're going to be doing a deep dive into processing round workpieces using the XTOOL F2 ULTRA as well as the RA2 Pro Rotary module. Now I've got a lot of different examples and workpieces to get through, so naturally we are going to run into some challenges along the way, but not to worry, we're going to solve those problems together. And I've even got a bunch of new upgrades and accessories for the F2 ULTRA as well as the RA2 Pro Rotary module. And towards the end of the video, I'm even going to show you guys how to process some round workpieces without the use of the rotary module. So be sure to watch right to the end so you catch that. Got a lot to get through. Let's go.
This is the RA2 Pro, and you can see that I have it assembled in chuck mode. You can see that there's one extra gray piece there. We'll get to that in a minute, but otherwise this is the standard RA2 kit in chuck mode, and then we'll line it up here on the F2 ULTRA base plate. On the base plate, there are two alignment marks that you would normally line up the front edge of the RA2 base with, and this would ensure that the rotating axis of your workpiece is in line with the center of the machine. Now, one of the issues here is that if you have a very long workpiece and you want to get more of that inside of the workable area, you would need to pull this entire RA2 mechanism backwards. Now the RA2 base is really only in contact with one of these notches, and the other one you're going to have to do a little bit of guesswork. Now, without any attachments, this does seem to work better or make more sense with the rollers. And with the rollers, you wouldn't have to pull the whole RA2 back to fit larger pieces in. But if you guys have worked with circular workpieces before, you'll know that the chuck is much more flexible than the rollers, because of course with the rollers, you would never be able to engrave things with handles. Objects with handles would not be able to rotate continuously on the rollers as they would hit, and it's also the case here with the standard RA2 kit. The handles oftentimes hit the bottom base. And this is even more so the case with much larger workpieces like these 40-ounce tumblers and water bottles that are very popular right now. There's absolutely no chance this thing is rotating all around, and you'll definitely have to pull that thing back to get the entire water bottle or tumbler to fit inside of the workable area. The other challenge that you'll run into is working with tapered tumblers and mugs. These are very challenging to do with the rollers. Once you start rolling the tapered surface on the rollers, it'll want to walk down the rollers and move. And even here on the chuck, the tapered surface is not parallel with the machine, and this is going to skew your graphic or image. Therefore, if you want to use the F2 ULTRA with the RA2 and process the widest variety of round workpieces, then I've got a solution for you. This is my RA2 tilt mechanism kit that you can find on my website, and I've already got versions for the F1 ULTRA, F1, D1, S1, etc. Right now you're looking at what's included with the F2 ULTRA kit, and I'm going to walk you guys through how to assemble it on your RA2, and then we'll go through all of the examples and I'll show you how it's going to solve all of those aforementioned problems. And so the very first thing we need to do here is some minor disassembly of your RA2. And at the back of the entire RA2 mechanism, there are these two long M3 button head cap screws, and you're going to want to pull them out and put them aside and keep them because we're going to need them in the next step here. We're going to be attaching the entire RA2 rotary chuck module to the tilt mechanism body. There's a marking on the tilt body that says chuck side, and you're going to line that up with the chuck side of the RA2 body, and you're going to be reusing the exact same holes that you pull those long M3 button head cap screws out of, and you're going to be lining those up with the holes on the tilt body. The long M3 screws go through, and they should pass all the way to the other side, and you can tighten them down. If you're finding that the screws are a little tight to get through, there is a large M5 socket head cap screw on this side of the tilt body, so it's the upper one, that you can give a quarter turn. You don't want to completely loosen it off, you don't want to go more than a half turn, just maybe a quarter turn, and that'll loosen up those rotating arms and give you a little more slack to get the long M3 screws through. However, in most circumstances, you shouldn't have to adjust that M5 screw, but I just wanted to bring that to your attention just in case. Since we normally don't have to make any adjustments to that upper M5 screw, it's the lower one that is going to enable us to tilt the entire RA2 body. And again, you shouldn't really have to touch that upper one. And one other friendly reminder, those M3s at the back, you don't need to over tighten them either, just get them snug. Now we need to get that entire assembly mounted onto the original RA2 base and inside of the tilt hardware kit you'll find these small M3 square nuts, and they'll slide directly into the channels on the RA2 base. And I would recommend you doing it from this side of the base here, where you can seat them flat on this surface, and then you can just draw them in with a screwdriver or an Allen key. Now, they are intended to be a fairly snug fit inside of the channel so they don't rotate. So if you're having a hard time getting them in there, try flipping them upside down if they won't fit in one direction. Inside the hardware kit, you'll also find 4 M3x10 socket head cap screws and washers, and this is what we're going to use to mount this assembly to the RA2 base, and those M3 socket head cap screws will thread into the M3 square nuts. At this point in the assembly, you'll just want to start threading them, and you don't necessarily want to tighten them all the way down, because we're going to want to make some adjustments to the position of the rotary module on top of the RA2 base later in this setup. So at this point, this is what your assembly should look like, and note that the chuck is facing the chuck side on the tilt body where there's that text, and it's facing those notches in the RA2 base. This is very important because that RA2 base is asymmetrical. Now I'm going to temporarily give those M3s a half turn to lock them down onto the base so this thing doesn't slide around, and demonstrate how it's supposed to look when it's tightened down. When looking at this assembly with the chuck on the left-hand side, the edges of the RA2 tilt mechanism will line up with the edges of the RA2 base. So this face here will line up with this face of the RA2 base. And if you're not entirely confident in getting these things lined up by hand or eye, you can use a speed square, as I was just showing in this clip. And one other little upgrade that I've got here that is separate from the tilt kit, but I do find makes life so much easier when doing these round tumblers, is the backstop and bubble level kit. And this is that gray piece that I pointed out earlier in this video. So this is the backstop, and you can see that I just got to remove the chuck jaws from the RA2, slide on the backstop, and put the chuck jaws back on top. And now with both the tilt mechanism and the backstop installed, you can see how quickly you can set up a tapered tumbler. So you can get the tumbler on top of the RA2 chuck jaws. You can butt it up right against the backstop so you'll know that it's going to rotate perfectly along the RA2's center axis. We can tighten it up, and now we can find the perfect angle for our tapered tumbler, and we can use the bubble level holder that comes with the backstop kit. And that will line up the bubble level perfectly along the axis of rotation of our workpiece. And then we can tighten down the one screw at the bottom of our tilt mechanism kit, and our tumbler is now perfectly aligned with the machine and it's ready to be processed. Switching over to a workpiece that's not tapered, but does have a handle that would have previously hit the RA2 base, you can see that I've got the level on there indicating that the surface of this mug is level, and I've tightened down the tilt kit in the level position, and you can see the tilt kit adds some height, so now the handle no longer hits the base. So the tilt mechanism alone appears to have solved many of our issues, but now let's take a look at the rest of the kit and see how it's going to work with the F2 Ultra. The kit will come with these 3 pieces that we are going to need to assemble together to make up one of the mounts that mounts to the base of the F2 Ultra. Now included with the kit are these 4 coarse threaded M4x10 screws that have a Phillips head drive. They're going to be used to assemble these 3 pieces together, and there's a paper instruction that's included with the kit, but those coarse threads will bite into the plastic, and the pieces have been designed that they'll only fit together one way. Once it's together, we'll just put that aside and we'll come back to it in a moment. And then we've got this other piece here, which I call the RA2 support, and you'll find 2 more M3x10 socket head cap screws that go into the back of this support piece. So we're going to take that support piece and we're going to screw that into the right hand side of the back of the RA2 base plate. There are 2 existing holes in the base plate. They're already threaded, and those screws should line up perfectly. And just remember, as with all of the other screws, there's absolutely no need here to over tighten them. Now we can come back to this bracket here and get it mounted to the base of the F2 Ultra. And you'll see it lines up with the right hand side of the base, and you're going to want to use these 4 M4x10 socket head cap screws included with the kit to secure this bracket to the base. Pay close attention here to which holes I'm using to secure it to the base, as there are multiple options and we want it in these holes here. So the whole RA2 mechanism is now centered on the F2 Ultra base plate. And also with the whole assembly on top of the machine, it no longer wants to tip over the edge, and you can move it back and forth. You have an incredible amount of flexibility to position the RA2. So now let's have a look at a workpiece setup example and how we can use this thing practically. So I have this tumbler here, and you can see it has a slight taper to it. I'm going to fix it inside of the chuck jaws, and then I'm going to slide it towards the middle of the F2 Ultra so that it's within the workable area. But now, because of the taper, we're going to need to tilt this thing. I'll use my hex key to loosen off the M5 screw at the bottom of the tilt mechanism, and now I can begin to tilt the whole workpiece upwards and use the bubble level with the bubble level holder to try and get the top surface level with the machine. And I say with the machine because if your table is not level, then you want your bubble level to match whatever it's reading when you place it on the base plate of your machine. Now, unless I'm engraving a very small cup or mug, I always like to use the steady rest. It just gives you that extra layer of stability and assurance that your workpiece is not going to slip out or move, and it only takes a moment to set up. So I almost always use it, and I would recommend that you use it as well. Now we can use the buttons on the front of the F2 Ultra controller to set the focus to the top of our workpiece. You can see here that I've got my blue and red dot aligned, and because I'm using the tilt mechanism kit, the laser dots are perfectly centered with the center axis of rotation of the workpiece. You don't have to fiddle around with it or do that manually. It's all done for you. And finally, I can just plug in the USB connector of the RA2 into the top port on the front of the F2 Ultra. If you're trying to engrave on a 40-ounce tumbler, you've got a very similar situation here where the handle now fits. In some cases, if you're trying to do a full wrap, which we'll cover later in this video, you can remove the handle, but if you have one of these that the handle cannot be removed, the good news is it still fits. And I still would recommend supporting the other end with the steady rest because the 40-ounce tumblers are quite heavy. The other thing to consider with the 40-ounce tumblers is that they have a very large outer diameter, and in some cases you may need more height. So in this clip here, you can see that I've removed the whole tilt mechanism from the metal base, and we can actually secure it right onto this mount. There are 4 brass inserts that you can thread this thing down onto, and you'll gain back the height of the metal base, which is about 10 millimeters. So that's one way to gain back some Z height, but there is another trick here where we can remove the support piece on the back of the RA2 metal base. And now with the F2 Ultra, because it sits higher up off the ground, we can slide this whole thing underneath of the F2 Ultra, and this mounting bracket will act as a guide to keep the whole thing centered. Now we have a lot more height to work with, and if you need to get the RA2 closer to the F2 Ultra base, this center portion of this plastic mount can be removed. If you recall earlier in the video, it was assembled in 3 pieces, and those 2 screws on either side can be removed, and you can pull out that center part, and the whole thing can shift right up to the edge of the F2 Ultra base. The 2 outer pieces that I like to call kind of like the wings, those will remain bolted down to the F2 Ultra base, and they will still act as a centering guide for the whole RA2 mechanism. So let's start off here with a pretty simple example and establish some baseline settings for tumblers on the F2 Ultra. I've got a straight cylindrical mug in the chuck, and you can see it's got a handle. You can also see that it's got some previous engravings on there, but we're just going to be using this as a sacrificial test piece, so ignore those for now. I've gone ahead and slid the entire RA2 over so the mug is centered in the work area. You can see I've taken the measurement on the base of the machine, and I'm going to use the tilt mechanism to make sure that the top surface of the mug is level with the machine frame. I've got the focus set to the top of the surface, and because of the tilt mechanism, it's automatically centered. Now, inside of XTOOL Creative Space, we need to select the Chuck Use Rotary attachment up at the top. And right beside that is a field where we can enter either the diameter or the perimeter of this mug, and in this case I'm going to use the diameter, and it's 88 millimeters. Beside that input field, there's a new button that allows you to have a 3D model preview of your workpiece. I'll show you guys that later, but for now in the material selection, I'll go ahead and select one of these red tumblers because this is pretty representative of what we have. So we'll see how the XTOOL Material Easy Set library settings match up with our actual material. Now, you may have noticed that as I selected that material, I had to go back and enter in the diameter again. For some reason, it disappeared. I also pushed the snapshot picture so we can see what's in our workspace, and you can see that there's a green line that goes right down the middle. And if you haven't used this before, this is the center axis of rotation of our workpiece. And we are going to take a graphic that I've just imported. It's an SVG file. I'm going to line that up right with the center. In the physical workpiece setup, you may have noticed that I had the handle pointing directly straight down, and that's because I knew right up at the top of the mug here, there's a blank space where we can do some test engraves. So I've gone ahead and taken that graphic, and now I've copied and pasted it because we're going to set up a few different tests. So the first one, I had selected the MOPA IR reference settings, and the second one, I'm going to select the blue light settings. And in this early version of XTOOL Creative Space with the F2 Ultra, you may have noticed that the blue light there, the text was actually in Chinese. I'm sure that's just a small bug that will get worked out by XTOOL, but for now we'll process this. And don't forget, with the rotary tool, the lid will likely be open and you'll want to wear some laser safety glasses. I've got some of those glasses for sale on my website, embracemaking.com, that are suitable for both blue lasers as well as IR lasers, so go check those out. Before running any job, I would recommend using the framing button to make sure that your graphics are going to end up where you want them on your workpiece. And I've gone ahead and processed this job. Right away, I could tell the skull at the top, which was the MOPA IR laser, was under processed, and the blue light one at the bottom, that one looked a little over processed. I'm going to try and clean it up. So I've gone back into XTOOL Creative Space, and I've changed that one over to the MOPA IR settings just to see if I run a pass with the IR laser, if it's going to clean up all the black soot and make it look quite a bit better. Now, it did seem to work a little bit, but there's still quite a bit of charring around the blue light laser. I noticed while it was being processed, there was a lot of flames being produced. So I think the blue light settings are too aggressive to start with, but it does give us a nice starting point that we can work with. So we'll go back into XTOOL Creative Space and we'll try something else. So what I'm going to do here is I'm going to add another skull down at the bottom, and this one here is going to have two layers. So you'll see a black layer and a yellow layer, and I'm also going to take the first skull that we processed, and I'm going to do a second pass of the MOPA IR just to see if we can get reasonable results with just the IR laser. But the real focus here is the one that you see in yellow. So that's got two layers. It's got a black layer underneath, which is the blue light, and then it's got the yellow layer on top, which is the MOPA IR layer. And so what I've done is on the black layer at the bottom, I've reduced the power of the blue light laser so we get less scorching and burning. And then I still have that yellow layer, which is the MOPA IR, and that is going to be the cleanup pass on this third skull at the bottom. The other thing I'm going to do, which is very important, and if you're not already aware, is change the order in which these things are being processed. So there's the little three dots beside the process button, which you can press, and I'm going to change that to by layer. So in the layer section up in the top left, you'll see that I've got the black layer first, then the yellow layer. So the black layer being the blue light laser, and the yellow layer being the MOPA IR. This is a very powerful and useful feature, especially when you're trying to achieve colors using the MOPA IR laser. However, it's also great for just running jobs like this in one shot, so you don't have to stop it and restart it, where you're breaking your job down into two parts, being the blue light first and then the IR second. You can just press go once. And you can see here that the results are better. However, even with the slightly lower blue light power settings, we're still seeing some scorching. So I went ahead and I tried this many more times just to dial in the perfect settings. And this is what I've got for these red tumblers. And this is going to work, I think, for a lot of other colors that have a thicker powder coated surface. And so I've basically got three different settings here, and each one has a fairly distinct look, and we're going to take a look at each one of those on this red stainless mug. Each one of these uses the blue laser first to remove the bulk of the powder coat, and then followed by the fiber laser for a cleanup pass. And you'll see the settings here that I'm going to flash up on the screen for each one. So the bright stainless is first, then we're taking a look at the true stainless, and finally we're going to look at the white stainless. So just pause the video at any point so you can copy those settings for your own use. You can see how each one does look distinctly different from the other. But the thing that is common to them all is that they all look very good, and I've completely gotten rid of those scorch marks, so you're going to get a nice clean result. Now let's go ahead and move on to a slightly different example. This one is a tapered tumbler, and this one also has a thin painted surface. So it's not going to be that thick powder coat. So we're going to use some different settings here. But with the tapered surface, we do need to make some adjustments to the tilt mechanism. So you see I've got the bubble level, and I'm going to use my bubble level holder to put that on top of the tapered surface and make the necessary adjustments such that that top surface is now parallel with the machine frame. I've also got my focus set on that top surface, and now in XTOOL Creative Space, I'm going to try and find a suitable material. So we'll head into the Easy Set Material library, we'll select F2 Ultra, I'm going to change the material type to metal, and we'll see if we can find anything in here. And there are quite a few options, but the workpiece that we have is sort of a light green color, so I'm going to use the search function at the top to search for green. And then I'll go ahead and settle on this army green plastic sprayed 304 stainless mug here. Just remember that once you select it in the Easy Set Material library, you still have to go back up into the corner and now select it because it only put it in your favorites. So now we've actually got the settings in there, and I've imported this PNG graphic of the Starbucks logo. I'm going to use the image trace option, and I'm going to turn it into a vector, just because I find that the vector images are so much more easy to work with in terms of reference settings. And so once it's traced, I've deleted the original image, and then I'm going to go back up to the top and I'm going to enter in the diameter of our workpiece. And in this case, it's tapered, so one side is bigger than the other. I'll take the measurement right in the middle, which turns out to be around 85 millimeters. Then I'll use the snapshot button in the top right to get an image of our work area. I'm going to resize and reposition the graphic. I'm also going to change which layer it's on, and I wasn't quite happy with the reference settings there for the IR laser, so I'm going to change those as well, make it a little closer to what we did with the red tumbler in the previous example. And I'm also going to take the graphic, I'm going to copy and paste it, and I'm going to switch it to a different layer. I've changed it to the blue layer, and for the blue layer, I'm going to change the processing type to the blue light. And I could tell already that the reference settings are much too high for something with a thin painted surface. Going to get a lot of burning, so I've reduced the power down to 23% on the blue light laser. And then I'll take the two identical graphics on different layers and just align them, because this is also going to be one of those examples where we are going to process them by layer. So you'll see that I've got the blue layer first, so the blue laser going first, removing the bulk of the material, followed up by the IR laser, which is going to do a cleanup pass, and we should hopefully get a very clean and bright looking graphic. And while I was explaining all of that, I also used the framing tool just to make sure that the graphic is going to be exactly where I want it on the workpiece. Then I've gone ahead and clicked process, and you can see that this job here should take about 4 minutes to complete. While this job was running, I didn't observe any burning during the blue light laser processing, which was a very good sign, so I didn't expect to see any charring. But what I did notice once the job was done, that the graphic looked nice and bright, which was a great start, but it also had a certain roughness to it, which from my experience I would attribute to too much heat. If the stainless steel starts to take on a darker color or perhaps even a golden hue, that's when I know that I need to dial back the settings a little bit. I really want that stainless steel to be bright and silver and pop. So what I'm going to do is go back into XTOOL Creative Space and make some very slight changes here. So in the blue light laser section, I'm going to reduce the power to 20%. And for the IR cleanup pass, I'm going to take a different approach and reduce the lines per centimeter from 260 down to 220 lines per centimeter. And these settings here are going to produce the best results, at least for these very thin painted stainless steel tumblers. And again, these are not the stainless steel tumblers with a thick powder coat on them. It just appears to be a very thin colored paint applied to them. And this is what that looks like. And you can see that this is a much brighter and crisper and more clear result. And this is the kind of brightness in the stainless steel that I personally prefer, and this is what I'm shooting for with a lot of my settings. Now, just a moment ago, I mentioned that overprocessing or adding even more heat can lead to a darker colored stainless steel. And I've got a different example here where we are going to use the IR laser, and we're going to be applying quite a bit of heat in a small area, and we're going to get a nice black color. And so I have this logo here, which is the Shell Petroleum Company logo. You may recognize it. And it is broken up into several different layers, and I'm going to explain each one. So on the left hand side, you can see the various shapes as part of this group, which makes up the logo. And we're going to drill right down to the first layer, which is the blue light laser. And I'll be engraving this on another one of these thinly painted stainless steel tumblers. So the blue light laser on the first layer is going to be set to 20% at 400 millimeters per second, and that's going to remove the bulk of the paint. Then on the second layer above that, the yellow layer, this is going to be the cleanup pass on our MOPA IR laser. So we'll go back to those settings that I just showed you at 13% power, 400 millimeters per second, 220 lines per centimeter, a pulse width of 200 nanoseconds, and a frequency of 48 kilohertz. Now on the layer above that, we've got two. We've got a green one and then we've got a black one. Now the green one, I'm going to attempt to get some kind of color on the stainless. So the first two layers cleaned it up, and now we're working with bare stainless steel. So in the green layer, I've got some settings there from a previous video where I try to color stainless steel, and that's a little more difficult to do. So I'm just really taking a stab at those settings. Transferring those color settings from flat processing to the rotary module is very difficult because the rotary module only has a maximum speed of 400 millimeters per second. So I'm really guessing at the rest of the settings there to try and get a yellow color. And you can see the final result didn't quite work out perfectly. It's not really a great yellow color in the middle, but you'll notice that the black outline looks amazing. And to get that black color, I used the color engrave option and had the settings set to 17.5% power, 150 millimeters per second, 2500 lines per centimeter, 80 nanosecond pulse width, and 90 kilohertz frequency. Moving on, we're going to do a full wrap design on this can cooler, and it has a slightly thicker powder coated stainless steel exterior, and I really like the results from the previous example blackening the stainless steel. So we're going to do something similar here. The can cooler is just a regular cylindrical object. There's no taper to it, so you could see when I had set it up, I do not have it tilted, and I also have it supported with the steady rest. Now inside of XTOOL Creative Space, I have my design, and this thing needs to be the perfect dimensions in order to get a nice clean full wrap around this can cooler. So the diameter of the can cooler is 80 millimeters. So the length of the graphic needs to be 80 millimeters times pi 3.14, and we get roughly 252 millimeters in length. And you can see here that I'm going to rotate the image 90 degrees. Now the height of the image is going to match the height of the can cooler. And one trick I use in order to get an accurate representation of the graphic on the can cooler while framing is I create that red rectangular object behind the graphic, because this graphic is not a perfect rectangle. So I put this layer behind there, I temporarily enable the output, and then when I go to frame it, I'm basically just framing a giant rectangle, and it makes it very clear where the graphic is going to end up. And then once I'm ready to process this thing, I just disable the output of that red rectangle and I hide it. So you'll see here that this graphic is actually just composed of two compound vectors. One of them is the American flag and the other one is the soldier in the foreground. And now that I'm happy with the position of this graphic, what I'm going to do is I'm going to take this group and I'm just going to copy and paste it and align it with the first graphic, because again, the position is where I need it to be, and you'll see that I have duplicates now of each of those compound vectors. Now the one vector, the soldier in the foreground, I'm going to copy that particular one and I'm going to paste it above all of the rest. So now that particular compound vector, the soldier, I have 3 copies of it, and I've set the topmost copy to the black layer. And then I'm going to do the exact same thing that I've done in all of the previous examples, where the very bottom layer, the first layer that's going to get processed, is going to be the blue light laser. And again, because this is a slightly thicker powder coated coating on this can cooler, I'm going with the 30% power, 400 millimeters per second, and 300 lines per centimeter for the blue light laser. And again, that's our first layer. Now for the yellow layer, which I'm going to make reappear right now, I'm going to set all of this to the MOPA IR laser, 13% power, 400 millimeters per second, lines per centimeter of 260, a pulse width of 200 nanoseconds, and the frequency I'm going to leave at 48 kilohertz. And this will do the exact same thing that it's done in all of the previous examples. The blue light laser will remove the bulk of the material, the MOPA IR will do the cleanup pass, and now on this third vector, which is again just the soldier in the foreground, I'm going to leave the American flag in the background, so that's going to be stainless steel. So this soldier in the foreground is going to get an extra step of being processed here. I'm going to use the color engrave option, 17.5% with the MOPA IR laser, 150 millimeters per second, 2500 lines per centimeter, a pulse width of 80 nanoseconds, and the frequency at 90 kilohertz. And what this is going to do is it's going to take that soldier vector and it's going to turn it black. So the effect that we should get in the end is a nice bright silver American flag in the background with a soldier in a dark black color in the foreground. And just a reminder to do this in the top left hand corner in your layers section, make sure you have all your layers in the appropriate order so that they will get processed in the right order. And another reminder here is that when we are doing these dark black colors, or if you're trying to achieve any other color, this will take a long time. In order to blacken that stainless steel, the lines per centimeter value is so high that this single cooler took about 5 hours to complete. So if you're doing something like this and you're running a business, that's going to be up to you whether or not this is economically viable for you to do. You would have to price it accordingly, but as you can see, the result is excellent. Now, you'll also see here, I've just pointed out that on the original tumbler, there was a logo that said Hydra Gear. So unfortunately, I didn't do a good enough job of lining up the graphic to engrave over that. And you can also see that maybe I had the length of the graphic ever so slightly too long, as there is a slight overlap. But for a first try, I think this thing turned out looking incredible. And I've rubbed my finger over the black stainless steel to show you that there is no layer of soot. It's perfectly clean, and the MOPA IR laser does an amazing job of taking that stainless steel and turning it a really smooth and deep looking black color. Being able to create this black color on stainless steel tumblers is an amazing asset, because now when you're working with lighter colored tumblers such as, let's say, white or yellow, this really is going to make the graphics pop. Whereas previously, if you're just removing the paint and you're getting the stainless color, when it's against something lighter, sometimes it tends to get hidden and you don't see the graphic as well. And this was the case on these pink can coolers that I was previously working with, and this time around I'm going to use silver and black to hopefully create a stunning image with a lot of contrast. So what I've done is I've imported a vector in the same way that I did with the previous example, and I've split it up into multiple layers. Again, the exact same way that I did with the previous example, and instead of the red rectangle in the background, I've just got the rectangle now in the background set to purple, and this again is going to help me frame this better on top of this can cooler. And I'm going to remove the purple layer, I'm going to disable its output so it doesn't get engraved, and I'm going to reuse all of the same settings that I did from the previous example, and you'll just see that I've selected some of those flowers in the vector shape, and I've set some of those to the black layer and obviously given them the same settings to create a black color on those flowers. And this was another one of these jobs that was going to take many hours, and several hours in, unfortunately, I noticed that something was going wrong. And I just wanted to share this with you guys so you don't lose many hours of processing time. And it was such a simple mistake in the actual physical setup, nothing to do with the machine itself or the graphic setup. These can coolers have a seal on the end, and I happened to chuck up this piece inside of this seal, and I just didn't realize that it threaded out of the can cooler. And during the job, I guess that seal became loose, and the stainless steel body started to rotate at a different rate of speed than the seal, which was the thing that was in the chuck. So what ended up happening here was that I got sort of a psychedelic looking piece where the layers shifted. So the blue light laser, the IR laser, and then the blackening step, none of those lined up perfect, and they were off ever so slightly. In the future, I'll know to remove that seal and clamp down directly on the stainless steel so this doesn't happen again. Now, before moving on to the next example, I want to take a very brief moment here and just point out that when we are engraving these tumblers, we are vaporizing the paint or powder coat, and I can't tell you what's in there, but I can guarantee it's not great for you to breathe in. You're going to want to invest into some sort of smoke and fume extraction system, and you have several different options. XTOOL has their AP2, which is their fume filtration system, which I've covered in a previous video, and they also have their IF2, and that is their very powerful extraction fan. I'll put links to those in the video description down below, and I love these two because they interface with XTOOL machines very well with a Bluetooth connection, and everything just happens automatically. However, there are less expensive options, such as these more generic inline duct fans. Oftentimes these come in a 4-inch diameter. And on my website, I've got tons of different adapters that you can use to build your custom fume extraction system and convert XTOOL hose to 4-inch diameter for these inline duct fans, as well as other adapters like splice connections to connect XTOOL hoses together, and so much more. So I'd encourage you guys to go check that out. I'll put links in the video description down below, and I'll also put links to that generic inline duct fan so you guys can explore your options and protect your lungs. Moving on, I'm going to attempt a color engrave on a bare stainless tumbler. Now this one is tapered, so in this setup, I'm going to use the tilt mechanism to tilt this tumbler upwards and get that top surface parallel with the machine frame. And if you've been skipping through this video and you hadn't seen the earlier example with the tapered tumbler, then I'll just show again that all you need to do with the tilt mechanism is loosen off the 1 M5 bolt at the bottom, move the tumbler into the position you want, and then tighten it back down. And for good measure, I've just again shown here with the bubble level that the top surface is parallel with the machine frame. With our workpiece now at the appropriate angle, I'm going to bring in the steady rest, and this is a bit of a larger workpiece. So again, the steady rest is fantastic for making sure that this setup is not going to move at all, and we're going to get the best possible result. It's also worth mentioning that employing all of these various tools makes consistency and repeatability very quick and easy when you're batch processing tumblers for your business. Now flipping over to XTOOL Creative Space, you can see that I've got 6 individual graphics, and I want to plan these such that I'm going to get a nice full wrap design, and they're all going to be spaced evenly. So what I've done is I've got the background rectangle, and the overall length of that rectangle is going to be the diameter of the tumbler, 85 millimeters times 3.14, and it's going to give me an overall height of 267 millimeters. So that's the long edge of that peach colored rectangle. And then you can see that I've got a few other blue rectangles in the foreground, and those are going to be all the same size, and I've got all of my graphics placed in between those. So essentially I'm just spacing out those individual vector graphics nice and even. And then taking a closer look at these vector graphics themselves, you can see that they are made up of many different shapes. And I'm not going to lie, this process is extremely tedious. I've prepared the graphics ahead of time in Adobe Illustrator, and then I've brought them in here, and I'm just grouping all of these similar colors. So you can see I've got all the colors grouped into different layers. The black layer will eventually turn out to be black engraved on the stainless steel tumbler, and then the blue, green, red, yellow, cyan, and orange, those are all going to be colors that I'm going to be shooting for using the MOPA IR laser, but honestly, there's no guarantee that I'm going to actually achieve those colors. I made a previous video discussing the challenges of achieving consistency with colors on MOPA IR lasers, so I'd encourage you guys to go and watch that. But essentially all of the work that I put into trying to find settings for the various colors on stainless steel in that previous video, all of that work is gone out the window, because with the RA2, the maximum speed that you can set is 400 millimeters per second. So in the previous video, if I had, let's say, a setting that worked to achieve a blue color, but the speed was higher than 400 millimeters per second, I can't use those settings here with the RA2. Therefore, to get the colors to work on the RA2 reliably and consistency, I'm gonna have to do hours and hours of testing. And I'll be honest, I just don't have enough of these bare stainless steel tumblers to sacrifice and spend hours of testing to find those colors. So what I'm going to do here is just make some very educated guesses on the settings, and then I'm going to run this job. And on the screen right now, I'll flash up the various settings that I did use so you can see what my educated guesses were, and then we'll see in a few moments here how those will turn out and if we get any colors at all. And so at this point, you may be wondering why I'm even sharing this example at all if I don't have settings that are guaranteed to work and produce vibrant colors. And that is kind of the point. Color engraving is very challenging, it's very difficult, and it will require a lot of experimentation. So I just want to share with you that this process is normal, and if you're not getting immediate results, don't panic and try not to get too frustrated. The color settings are very sensitive, and you're going to have to put in a lot of seat time into testing, and you're probably going to waste a lot of material to find the settings that work for you. With all of that said, I've now got all of my best guess settings input into XTOOL Creative Space, and the one final feature I want to show you here is the model preview. So this is a new button, and you can go ahead and press that, and it's going to give you a really amazing 3D representation of what your tumbler should look like with all of your graphics, and you can kind of get a sense of if you've spaced them all out properly. Now, it's not going to show you if your taper is tumblered, it's just going to use a regular cylindrical object, but it's still pretty cool. And before I hit that process button, you will also see that I went into the processing settings. I've selected by layer, and of course, like all of the other examples I showed you in this video, I organized my layers in the order that I wanted them to be processed. Now in this case, because the stainless steel tumbler was completely bare and there was no paint or powder coat on it, the order wasn't too important because I wasn't burning off any of that paint or powder coat. And in this case, I was just blackening the bare stainless and trying to get some colors. And you can see here that, not surprisingly, I didn't get the results that I'd wanted. Other than the settings for achieving a black color, which I knew would definitely work, none of the other colors really came through that well. I didn't get a single blue color, and I didn't show it in the video, but I did try and do several passes on some of these vector shapes to see if I could get a bluer color with multiple passes, but that was not something that I could achieve. In the Boston Bruins logo here, I did kind of get close to a yellow color. So those settings for yellow were actually not that bad of a guess. That could be a good starting point for some of you guys looking to achieve a yellow color. But otherwise, I didn't find a whole lot of success in the other colors. Perhaps the orangish reddish skin tone color in the Chicago Blackhawks logo was somewhat close, but a lot of the colors you'll notice were also very muted and not very vibrant. And this could be the settings themselves, but it could also be the material. I have no idea what grade of stainless steel that this tumbler is, and I believe that 304 stainless is probably one of the better grades to work with, where you might get more vibrant colors, but this particular workpiece might just be a lower grade of stainless steel. But despite the colors not working out, this example does show you that tapered tumblers are easy to process with the tilt mechanism. The graphics were crisp and clear, and the setup and approach that I showed you in XTOOL Creative Space of drawing out those rectangles and just using them to plan and position the vector logos does work very well, and hopefully that's a trick that you can also use for yourself. Next, we're going to perform a full wrap engrave on one of these very popular 40-ounce tumblers. Now I'm going to show the setup with this one here, and this one does not have a handle that can be removed, but if you're going to do a full wrap design, you will need a tumbler that has a removable handle. For this job, we're going to be using the steady rest as well as this squaring bracket that came with the F2 Ultra, my tilt mechanism kit. And the first thing we're going to do is loosen off the 4 M3 screws holding the tilt mechanism kit to the RA2 base. You only need to turn them a half turn. You don't want to remove those screws completely, and that's going to allow us to slide this back and forth on the metal base. Now that the tilt body is free to move back and forth, we're going to place the RA2 metal base in a position that is easy for us to reference and remember. So I'm just going to line up this edge here with the edge of the plastic bracket. Then I'm going to bring the 40-ounce tumbler and I'm going to get it set up in the chuck jaws. And for these, I do like to grip them on the outside. After that, I'll bring the steady rest, and you can see that for now, temporarily, I have it lined up with the edge of the base plate. But to give it an even more consistent position and to keep it squared up with the center axis of rotation, I'm going to use this squaring bracket. So I'm going to screw it down onto the base plate, and then I can butt the edge up of the steady rest against that angled bracket. Then I'm going to flip over to XTOOL Creative Space, and you can see I've already got it in the chuck mode. And in the diameter field, I'm going to enter in 100 millimeters, which is the outer diameter of the largest part of this tumbler. Now I've already preset this project here with these two rectangles that are 220 millimeters wide. So that is the maximum processing width for the F2 Ultra, and they're only 3 millimeters thick. I have both of these simple rectangles overlapping one another on top of the center axis of rotation. One of them is set to the blue light laser and the other one is set to the fiber IR laser. We're not going to process them just yet. For now, we're interested in framing them. So I'm going to press the framing button, and what we're looking to do here is set up the position of the tumbler such that the maximum width, so 220 millimeters of our processing area, falls within the area of the tumbler. Now, most of these 40-ounce tumblers are longer or taller than 220 millimeters, so there is going to be some area that is not going to get processed, and that's perfectly normal. And it was a little difficult to see in that clip because the framing happens so quickly, but the tumbler twitches a little bit, and the blue laser that gets projected onto that surface again should fall within the surface of the tumbler. And so you'll see me here starting to slide the tumbler over to the right hand side to make sure that the blue laser being projected on there falls on top of that tumbler. And once it does, and I'm happy with how the tumbler is positioned, I'm going to tighten down those M3 screws on the tilt body, so now it's secured to the metal base. So now we have the workpiece positioned properly side to side, but we do need to tilt it upwards in order to get a nice even engrave across this stepped surface. So you'll see that I've got this special tool here that I will make available on my website, embracemaking.com, and it's designed specifically for these 40-ounce tumblers. And the XTOOL RA2 bubble level slips into the top, and you can place that on top of the tumbler. And we want to get this part of the tool sitting flat on the cylindrical portion of the 40-ounce tumbler. And then this smaller section of the tool down here should be making contact with the lower stepped part of the tumbler. And these 40-ounce tumblers from different manufacturers are almost identical, but there are some slight differences between them. So you may have to slide the tool left to right a little bit to make sure that both parts of this tool are again making contact with both of those surfaces. Now we have the tool in the correct position, and what we're looking to do is similar to what we've done in previous examples. So the angle of the bubble level on top should match the angle of the bubble level when placed on the machine frame. Now it's probably not obvious, but the bubble level inside of that special holder is not parallel with the cylindrical or larger part of the 40-ounce tumbler surface. I've designed it to be on an angle that appropriately matches how these 40-ounce tumblers are stepped, and so it's going to give you the best possible position to get, again, a nice even engrave across these stepped surfaces. So you'll see that I had loosened off the M5 screw on the bottom of the tilt mechanism, and then what I've done is I've used the steady rest to make very fine adjustments to the angle of the tumbler so that the bubble level again matches the bubble level on the frame. Then I can tighten the M5 screw on the tilt mechanism and lock that angle in place. And there's a flat surface on this tool that we're going to be focusing on. And in order to do that, we need to now move the entire assembly over to the right. And this is again why I had set up the position using this angled bracket, as well as using the reference position of the RA2 metal base with the plastic bracket, because we're going to have to return back to that after we get the focus dialed in. So you'll see I move the whole assembly over to the right hand side, and now the blue and red dot laser should get focused on this surface on this tool. And this is going to set the focal height to the appropriate distance, again, across those various stepped surfaces to get the best result possible. Now I can easily move everything back into its original position because I have all of those references. And if you did everything correctly and precisely, the position or angle on the bubble level will not have changed once you put everything back to where it was, and the tumbler should rotate freely and very smooth. Now, to demonstrate that this setup does in fact work very well, I am going to process these long, thin rectangular strips. So in XTOOL Creative Space, you can see again that I've just got them set up with a blue light and a fiber IR process, and I'm going to run them. And this is a sacrificial test piece where you can see I've already done the test once and I'm doing it a second time. So when it's done and I rotate this piece downwards, you can see that the engraving is very uniform from left to right. The strip on the bottom was done previously, the one on the top was just done right now, and they look exactly the same because, again, I did the exact same process. And if you have a tumbler that you want to sacrifice as part of your test setup, then again, you can do the same thing, and you really want to make sure that the engraving is very uniform across that entire length, and you know your setup is secure and solid. And you can see here that even with the handle still attached, that with this whole process and the tilt mechanism, we've got plenty of clearance even for these 40-ounce tumblers with very large handles. So if you were just doing a logo on the cylindrical surface, you wouldn't have to go through this setup, you wouldn't need it tilted, but you'd still have clearance for the handle and you wouldn't have to remove it. This setup is specifically to get a full wrap design from top to bottom. Now we can go ahead and do that full wrap design on one of these XTOOL selected 40-ounce tumblers with a removable handle, and this one is special because underneath of that black paint there is an iridescent coated stainless steel surface. And these premium tumblers come with the screwdriver even to remove the screws for the handle, which I was surprised with, but they also come with some premium accessories like a stainless steel straw as well as a cleaning brush. And before we go ahead and process this, I do like cleaning the surface with alcohol pads. We can also just clean it with dish soap. Now I've got the XTOOL tumbler in the chuck jaws, and one tip here that I want to show you is that I recommend you line up the brackets that hold the handle with one of the chuck jaws, and it's not going to be entirely obvious right now why. It'll become more apparent as we go through the rest of this example, but essentially it's going to give us some sense of location and placement for our full wrap graphic. So I've got the handle rotated down towards the back of the machine, and the next chuck jaw is facing up, and I'm just going to push that a few degrees more towards the back of the machine, so it's not actually facing directly up. And that's going to be our starting point for these 40-ounce tumblers for a full wrap design. And you'll see that I once more used the tumbler leveling tool to check the angle on the new workpiece because we switched over from the test piece to this new XTOOL black tumbler. Now in XTOOL Creative Space, we can use the Easy Set material library and we can find this particular material. XTOOL does have it listed in the material library, and it does appear that they have options and settings for the F2 Ultra. However, when we do add it to our project and we check those settings, I can tell right away that these settings are not appropriate, and it looks like perhaps, at least at the time of the making of this video, that I'm going to have to find my own settings. In the future, I'm sure they will populate these settings for this particular material, but for now, I'll cut to the chase. I ran some test engraved strips at the bottom of the tumbler, so it's not going to be that noticeable once we do the full wrap engrave. And I was able to find some settings with just the blue light laser that burns away the black paint and preserves the iridescent color of the stainless steel underneath. Now then, XTOOL Creative Space, I got my full wrap graphic, and right now I have it centered on the center axis of rotation, but because of its overall height, it now falls outside of the processing area as reported by XTOOL Creative Space. Let's say if I hit that framing button. Therefore, we need to reposition it, so I'm going to click on the graphic and then enter in 0 in the Y coordinate position in the top left-hand corner of the screen. And the graphic is still centered side to side, but now top to bottom, you can see it's no longer centered on that green center axis of rotation line. And this is why a bit earlier I had mentioned to you guys to line up the brackets that hold the handle with one of the chuck jaws, and I explained how to position it. And now I'm going to further fine tune the tumbler's starting position, because what I'm shooting for here is the start and end of the graphic, so the seam, to line up with where the handle is, because it'll sort of get hidden behind that handle. It'll make the seam less noticeable. So what I've done is I've drawn in another rectangle of an arbitrary width, and I've got it set to a thickness of about 4 millimeters, but its Y position is at 0, and then I'm going to hit the framing button. And on the tumbler, what I'm looking for is for it to rotate back around during the framing process, and the projection of that small 4 millimeter strip should fall between the brackets that hold the handle. And that's going to tell me that I have the tumbler in the correct rotational starting position, so that the seam of the full wrap graphic also falls into that location. And this is why I explained earlier that if you line up those brackets with one of the chuck jaws, and then you just rotate all of that towards the back of the machine, so the next chuck jaw faces directly upwards, and then again you rotate it a few more degrees towards the back, this is going to get you into the correct ballpark for these 40-ounce tumblers. So for now, this is how I'm doing it, and hopefully in the future XTOOL can come up with some kind of a tool inside of XTOOL Creative Space to perhaps assist you with locating that seam. Now in terms of the settings, it's very simple. I've selected my vector graphic. I'm going to enable its output, and all it is 25% power with the blue light laser, 400 millimeters per second, and a line density of 300 lines per centimeter. If you have any other vector graphics, shapes, or the like that you used for the purpose of alignment like I did, be sure to disable their output or delete them. And then for good measure, I've framed the full wrap graphic one final time and then sent the whole design off for processing. And this full wrap design says it's going to take an hour and a half to complete. Now, if you followed along from start to finish, this entire process was quite time consuming to get it set up properly, but the results are worth it. And where you will find the time savings is when you're batch processing these tumblers. So once we have all of this position set up, I can just put the next tumbler in and press go. Taking a first look at this tumbler, I think it looks absolutely incredible, especially with that iridescent color in the background. Now, because this was just the blue light laser with no IR cleanup pass, there was a bit of soot buildup, and I went ahead and cleaned that off, and the colors are even brighter and more vibrant. During my testing, I did try some settings with an IR cleanup pass, but it seems to disrupt or destroy all of those colors hiding underneath of the black paint, so you'll just want to use the blue light laser with the settings that I showed you. The robust and precise setup paid dividends in this case, and the entire graphic looks absolutely flawless. There's no signs of the tumbler wobbling or moving, and most importantly, the graphic is completely uniform from top to bottom. And that's largely thanks to that 40-ounce tumbler tool that I showed you, where the bubble level fits in place, and it allows us to get the perfect angle of the tumbler. So again, we get a nice uniform graphic from top to bottom, and there's no areas that are too far away. Everything is nicely in focus across that entire surface, and the results are now very repeatable. I was also even able to get the graphic seam to line up reasonably well with that handle, so this was a great success. If you're looking to process rings on the F2 Ultra with the RA2, this is entirely possible. I outlined this process in great detail in a previous video using the F1 Ultra, and the good news is that these two machines, F1 Ultra and F2 Ultra, are very similar in this regard, nearly almost identical really. My tilt mechanism kit makes it very easy and simple to get the right angle for engraving these rings on the F2 Ultra. And as this video is getting pretty long at this point, plus I also ran out of ring blanks to demonstrate with, I would highly encourage you guys to go watch that F1 Ultra video, as I've got a lot of interesting tips and tricks in there, and I'll show you guys how to engrave the inside and the outsides of these rings. I'll put a link to that video in the top right hand corner of the screen right now. In all of my RA2 Rotary videos, I always show alternate approaches to processing round workpieces, and earlier in the video I showed this piece here that is included with my tilt mechanism kit. And although these clips here are taken from my F1 Ultra video, the same concept applies, where you can take this bracket and it allows you to attach the tilt mechanism body anywhere on the fixturing grid of the F1 or F2 Ultra. When using the rotary tool this way, you won't actually enter the rotary mode within XTOOL Creative Space because you will not be rotating the workpiece during engraving. At least not if you have the workpiece facing forward and backwards, as I'm showing in this example here. Now, if you do fixture your rotary kit facing left or right, then I guess you could still use it with the rotary option within XTOOL Creative Space, but like this, you'll just use it in flat engrave mode. And you may be wondering why you would want to use the rotary module in this way, and it's mainly for speed. So in XTOOL Creative Space, when you activate the rotary mode, you're limited to 400 millimeters per second speed. But in this particular case, as you'll see in this example, if you have a small logo or graphic that you're trying to engrave onto a round surface, you can get away with just using the flat engrave mode and the image looks just fine. And now you can use speeds faster than 400 millimeters per second. This will greatly improve efficiency, and using the RA2 chuck, you still have a nice secure way of holding your round workpieces. Now, if you don't yet even own XTOOL's RA2 Rotary module, perhaps you're not ready to make that investment just yet, and you're still wanting to dip your toes into processing round workpieces, then the alternative solution to that is using a V-block fixture. It will have its limitations, as you obviously will not be able to rotate the object around, but as I've demonstrated in previous videos using the XTOOL F1 as well as the F1 Ultra and some other machines, the V-block fixture can still be very useful. The V-block fixture, as with all of my fixtures, is originally sized for the XTOOL F1, and it can be fit onto the base plate of the F1 and F2 Ultra using this fixture adapter that you can find on my website. And it is compatible with both the F1 Ultra as well as the F2 Ultra because the base plate and the grid on those base plates are identical. The fixture adapter is adjustable, so you can use fixtures from me, maybe ones that you've created yourself, or even from other brands. And for even larger batch processing, you can set up the fixtures in a 2x2 grid for maximum efficiency. Right now we'll walk through an example with the V-block fixture. And so I have the focusing set to the base plate in the F2 Ultra, and I've got the fixture adapters installed, but all of those screws are slightly loose. Now in XTOOL Creative Space, we'll come in here and we'll draw a rectangle that will be 109mm by 109mm, and we'll set that to Engrave. We'll align it horizontally in the center and vertically in the center, and then we'll hit the framing button. Back at our machine, we'll get the projected outline of that rectangle, and this is where we are going to want to place our V-block, and it's going to ensure that this fixture is directly in the center. So we'll line up the outer edges with that projection, and then we can just tighten down all of the fixture adapters, and that's going to lock this thing in place. Now anything we put inside of this fixture is going to be perfectly centered. I have this 3D printed cylindrical cup, and as you can see, the V shape of the V-block holder holds it centered and secure. Now I'm going to set the focus on the top of this cup, but then I'm going to set it slightly out of focus, and I'm going to be focusing downwards into the cup, and that's because as the graphic that we engrave onto this thing is processed, it's going to engrave down the sides of the surface, so we want our focal point to be somewhere in the middle. Back in XTOOL Creative Space, I'm going to get rid of that rectangle that we used for the fixture alignment, and then I'm going to take a snapshot picture of our workspace, and you can see that we've got the V-block in the center with that black plastic cup sitting on top. I'll bring in my graphic. I'll spend a little bit of time here just rearranging and resizing it. If we're not using the rotary module, you have to imagine that obviously we can't wrap the graphic around the entire cup, and we have to be a little bit careful about how far down the sides that we're trying to engrave. And it looks like with the framing here, this is probably going to be the limit of what we can do. And of course, I can move around the physical object and get the graphic exactly where I want it to be on this cup. This plastic cup is 3D printed, and it's just black PLA. And to engrave 3D printed parts with black PLA, these are my settings. So I'll be using the MOPA IR laser. We'll be using 10% power, 750mm per second speed, 80 lines per centimeter. I'll leave the pulse width at 200 nanoseconds, the frequency at 60 kilohertz, and I'm going to be using an engraving angle of 45 degrees and the crosshatch. I've been marking my 3D printed parts for quite some time now with the IR lasers, going back to the original F1. I've also done it on the F1 Ultra and now also on the F2 Ultra, and it looks great. Black PLA has traditionally worked the best for me, although I have had some success with other colors, even gray, and usually it lightens the plastic, so typically the darker colors will work better. And on this result here, you can see how some of the outer letters, like the outside of that R and the X, are a bit brighter than the center portion, and that's because I focused perhaps slightly too far into the material. So you can make some adjustments, and in this one, I focused back up a little bit higher, and you can see the graphic was more consistent across the entire picture. So that's how easy it is to use the V-block fixture, and you can see how fast the engraving happens when you're not using the rotary module and you're just processing a small graphic. And if you check this thing out on my website, you'll see that on the newest V-block fixtures, I've got a feature where you can actually tilt objects with tapered surfaces, so you have even more flexibility with those objects. And one final thing I want to point out here about the V-block fixture is that I do try and make all of my fixtures and tools multi-purpose so you get the most value out of them. It will hold up to 9 standard size pencils and 5 of these aluminum bottle openers. I do my absolute best to make all of my tools and designs as flexible as possible so that in combination with these YouTube videos, you get the maximum amount of utility out of any of my tools. So head on over to embracemaking.com to find everything that you've seen in this video.
I hope you guys enjoyed this video and found it useful. These very thorough videos take a lot of time and effort to produce, so I'd really appreciate it if you guys like this video, dropped a comment in the comment section, or hit that subscribe button. I have a lot more F2 Ultra content coming, including a deep embossing video that you're not going to want to miss. Don't forget to also check my website, embracemaking.com, to find all of the upgrades and accessories that I've shown in this video. And don't forget to check the comment section down below, where I will put all of the relevant links to everything that I've mentioned in this video. Thank you guys so much for watching. See you next time.